Okay, hello everyone, my name is Matthew, and today we will learn about data frames in Pandas using Python, of course, and using Jupyter Notebook. Um, and also we will use a database called Adult from UCI Machine Learning repository. So I have already prepared this dataset for you. As you can see, it shows us some characteristics of people, of each person, whether they are male, female, what's their race, and stuff like that. And the target variable here is whether this person earns more than 50,000 or less. So probably this dataset might be used for some classification problem, but today we will focus on data frames in Pandas, and that's all. So first of all, as you can see, our data frame consists of columns, which are also variables, of index, this is the second part of our data set, and of course of values itself. So to check columns, we can use that columns method, and we have all the columns listed here for us. To check the values, we can call values method, and we will see that this is an array basically, an array of values. We can also check the index. Okay. What's more, what we can do more, we can check the shape of our data. It's more than 30,000 of rows and 15 columns. We can check all those information summarized up for us. So basically, that info method summarize all the information for us. We can see that this is a data frame. We can see our index. We can check the column names and whether they have some missing values or not. So basically here we can see that the H column has more than 30,000 not missing values. We can also check the type of our variable, whether it's integer or float or object. Object in Python is basically a string. So yes, two more really important methods. Those are head and tail. The head will show you the first 5 rows in default. You can call it even two rows, sorry. And the second method is tail. It shows you last 5 or last whatever number you give observations in your dataset. There is also a method called describe. It basically counts for you statistics, descriptive statistics like mean, standard deviation, minimum, maximum, median, for each numeric column in your dataset. So this might be really useful when you want to just quick look at your dataset. You can tell, for example, where if in each column there are some negative values, you can check it. Basically you can find any anomalies using this describe method. It's really fast. What's more, there is also a value counts method, which I will show you on the example of maybe race column. Let's take a race column and let's count those categories with value counts method. So as you can see, there are more than 27,000 of white people, 3,000 of black, and yeah, this is how value counts works basically. What we can do more, we can count really fast correlation, for example. So this is Pearson correlation, but you can also use other methods like Kendall or Spearman correlations. So as you can see, for example, age and capital gain are correlated on the level of approximately 7%. What we can do with such correlation, we can put it in heat map, for example, called dfcore. Let's take anode true, and as you can see, this data frame with correlations is now plotted or visualized with this heat map. It's really important method and really useful, I would say. With not true, you are simply giving those numbers here, showing those numbers here. You can change the style via this. You can change the style, for example, of your map or of your plot. Rainbow. So this might be useful. There are also there are some more methods in Pandas. You can check whether your data frame is empty, for example, or your single column is empty. It doesn't matter. You can check if your data frame consists of any missing values, like this. But now we have a whole data frame of only falses and trues. But let's take any on this, and you can see that there is no variable in our data set which consists of missing values. We can check it with another any. Yeah, so this is how we handle the missing data. There's also isNA method. It is the same as isNull in this particular example, so it works the same. How to check whether your column has negative values, for example. So let's take age. Let's say it's less than 0. It will show you each observation and say if this observation is this value is less than 0 or greater than 0, and call any on this, which will show you that there is no negative values in age column. Yep. You can do the same if you want to check whether there are some zeros in our column. So it's really those are really fast methods to validate your data, for example. Okay. There are two methods which I want to describe. Those are rename and replace. How to rename our data set? First of all, let's create new variable in our data frame. Let's call it new variable. Give a number of 5. Assign the number of 5 to it, and let's check our new variable. So it is called new variable. Sorry. Okay. And as you can see, there are only 5s here. And let's say that we want to rename this new variable to be maybe 5, to be named 5. So to do this, we need to call rename method, give columns equals new variable, and let's call it 5. And as you can see now, our new variable is called 5 right now. So this is a method. Rename method columns equals dictionary, and you simply specify. If you want to rename more variables, you just need to give comma and do the same. So this is how you rename. Okay, let's move further. Let's use replace now. So let's say that we want to replace our, I don't know, female with woman, for example. We don't want to have female here, but we want to have woman. So to do this, we need to use replace method on sex column probably, and let's check to replace value. To replace will be female. Value option will be, let's call it woman. Okay, it didn't work because here probably the female is not, we can check why it didn't work. So basically, let's take sex column, let's take the 5th observation, and as you can see, the string here consists of blank space. So to replace it basically, we need to add space here. Yeah, and as you can see now, we have our female changed for woman. So this works pretty well. So this was rename method and replace method. Let's move to slice, how to slice our data sets. So basically, if you want to slice our data set, you can just call your data frame and do double brackets, and now you can take all the information that you want, all the columns that you want. So let's take age, for example. Let's take maybe the first five columns, as you can see. So those will be like this. Let's remove this and check. Yeah, and as you can see, our data set is now, our subset is now consists only of 5 columns that we have chosen. So this is the first method of slicing the data frames, is the most easiest one, slicing by the columns. There are also 2 methods which I want to describe, lock and iLock. How lock and iLock works, I will show you, because it's the best way to learn those are just to show examples. So let's call lock. Let's take, for example, I need my columns one more time. So let's take, for example, people who are more than 35 years old, let's say if it works. Yeah, it probably works. So this is one way. Let's take also the people who are males, for example. So let's make ampersand, df sex equals, probably with space, with blank space, male. And yeah, as you can see, we have people who are aged greater than 35 and who are only males. And now in lock method, you are basically slicing by labels. So we give some labels here, and yeah, and there is also a comma here. This comma is really important because on the left side of the comma you are slicing the observations. On the right side of the comma you will slice the columns. So now if you want to take the columns, like let's take all those columns here like before, and maybe let's add the sex column so we can see that those are males. Yeah. Okay, and as you can see now, our data set consists of people who are aged more than 35, people who are males only, and we took the columns that we wanted to. So we took age, sex, work class, and those three columns left. So this is how you slice by labels. What's more interesting, what might be more interesting for you, is that if we take some, let's take some numeric variables, which will be quite big. Let me check, for example, capital loss, maximum, or capital gain, maximum 100,000 almost. So let's take capital gain. So let's also take people who have the capital gain greater than, I don't know, 50,000. Okay? But now I want to show you this method of underscore and what this underscore does. And let's take this column also, so we can see whether those people have the capital gain. Okay, as you can see, those people who have more than 50,000, they probably will have almost 100,000. But that's not the case. The case is that first of all, it worked. So we took all the people who are aged like this, who are males and who have capital gain more than 50,000. And what this underscore do is it helps us to read the number basically. So as you can see, for Python, this is 50,000, but this is also 50,000, but we can better see how many zeros are there. So for example, if you have 1 million, or let's say 100 million, like this, okay, it's not 100 million, it's 10 million, so let's add one more zero here. sorry, add one more zero here. Yeah, yeah, okay. And this will be 1 billion basically. So for Python this is 1 billion, but also wait, 1 2 3 1 2 3 1 2 3. Okay, so basically those two numbers are the same, so underscores helps us to read the huge numbers, and it doesn't change anything for Python. So this might be something useful and new for you. There's also other method of slicing the data. This is iloc method. And what iloc method is different from loc, it slices with indexes. So first of all, let's take all the data with two semicolons. You are taking all the rows and all the columns of your data. So this comma works the same. On the left side you are filtering observations, on the right side you are filtering columns basically. So we can change this. We can take, for example, the first 100 observations, and only, let's say, first 3 columns. And as you can see, it worked pretty well. It took 100 columns, observations, and only 3 columns. So this is great. This is what we wanted basically. So this is iloc method, and iloc method is also really great. So let's move forward further. How to create a data frame. So we have talked about lots of stuff here. We have talked about reading dataset is the most easiest way. How to get to the parts of data frames, and we showed some methods like shape, info, head, tail, describe, value counts, correlation, heat map with correlation, empty, is null, is NA, replace, rename, how to slice our data, with loc and iloc. And now how to build our data set. So basically we need to build it with series. So let's create the first series. It will be like 1 2 3 4 5. The second series will be like, let's make it string, 1 2 3 4 5. And now what we can do is we can get pd data frame, and we just need to give the dictionary here and call our column. Our column, let's name it numbers, and assign series 1, and let's say string numbers or strings, I don't know, and assign series 2. And as you can see, it worked pretty well. So you can you can create your own data frame using dictionaries, yes? So let's call it maybe df small. And df small looks like that. So that's one way. That's one way to create data frames. Now I will show you two methods, concatenation and joining the tables. So concatenations will be like if we have two data frames, we will join them like this, or concatenate them like this. And if we have two data frames like this, if you want to join them by columns, you just simply use join. So okay, so let's create two slices of our data frame. First slice will be called, let's say, iloc, take 100 rows, first 100 rows, and I don't know, all columns. Second slice will be take next 100 columns and 100 rows and all columns. So as you can see, we have a slice like this, all the columns and first 100 rows. The second slice will be all the columns and next 100 rows. So now to concatenate those, so if we check the, let's say, if you print, for example, df slice 1 shape, and you can print also the df slice that shape, you will see that we want to concatenate those. We have the same columns, but observations are different. So we want to concatenate those two with simple concat method and df slice 1, df slice 2, and as you can see, those have joined together. So we have all the columns that we had, but our observations now are concatenated basically, and we can call it concated, for example. Yeah. So this is how to concatenate two data frames and how basically concatenation works. Now, if you call shape on this, as you saw, 200 observations and 16 columns. Okay. Moving forward, I will show you how to join two columns, join two data frames, and to join those, we'll need to create two different data frames, and will be df iloc, for example. Take 100 first observations, the first 5 columns, and create second join data frame. It will take the same number of observations and the next 5 columns, I would say. So as you can see, we will now have the same number of observations, but the columns will be different. So now we will join those. It basically works like a merge. So we have those observations are the same. The 0 observation here is the same as 0 observation here. And now we want to join them, so we will glue those data frames with columns. Okay. So to join them, we need to, let's create joint. To join, basically, we need to first data frame, join, and add second data frame, df join 2. And as you can see, we have 100 rows and 10 columns, age, work class, yeah. So this worked for us pretty well, joined. Yeah. You can also, for example, let's look at our data frame. You can also say in Pandas that you want to check more than those first, I don't know how many rows are there, but like 10. So you can set options, pd set option, display max rows, and you can assign here, I don't know, 1000 for example, but let's take 100 rows, and let's take display max columns to be like 20. So we set our option, and now if you check our data frame, display max rows, wait, it didn't work or what? Display max rows, let's take 500. I'm not sure why it doesn't work. PD set option. I'm not sure, but let's take maybe concatenated. Okay, I think I'll have to put it right here, maybe, and then call our concatenated dataset again, and let's check if we can see all the 200 rows. Yeah, okay, so the option needs to be set before the data frame is done. So basically, it's the best way to put options right here below the libraries, for example. So this might be some important stuff. Yeah. So as you can see, we have now concatenated, and we can see each of the observation that we want, because we specified 500 of observations to be visible. So this is how it works, those options. Join method, you can check, of course, we had those describe method, as you remember, but we can also specify in Pandas. There are lots of different options to specify on a single column of statistics. So for example, let's take age, and we can call min on this age. We can call maximum on this age. We can call basically minimum, we can call standard deviation, we can call sum, for example, on this column. Skew, this is something new. Yeah, so basically you can use those statistics on a whole column. What's more in Pandas? What's really nice in Pandas, that there is a visualization tool in Pandas. So let's visualize. Yeah. So in Pandas, let's take for example our age, and let's say that we want a histogram of our age. So this looks like this. Let's take beans to be like 20, so we can see more specific. And this is the most easiest plot in Pandas. You can make much more, I would say, sophisticated. Let's make more advanced histograms. Like, let's take beans 20. Let's take by df dot female, and as you can see, now we have our histogram of age for female and male groups, grouped, let's say. Let's take maybe fixed size. We can change the fixed size to be slightly bigger. We can change the color for red if you want. We can now our data, our plots are in different scale. As you can see, the y-axis here is in different scale in both groups. We want the same axis to check the real distribution of those columns. So let's take share y equals false. Share y equals true. I should get, sorry. So as you can see now, the y is the same for this plot and this plot. So it's shared y-axis. As you can see, there are much more males than females in our dataset. That's the first conclusion on those histograms. But basically, this is how you can make those plots with pandas. Basically. I will show you some more advanced ways also to join all the methods that we learned together and then to plot. So maybe let's say that we want, let's take our log like here. Okay, let's take those. Let's take those and plot it, try to plot it somehow. Okay, we need our log probably, or maybe even not. Okay, no, let's not take log. It's not necessary. So as you can see, let's take for example. I want to create a scatter plot, so we need some numeric variables. So let's take, for example, hours per week. Let's check how many people, how long those people are working, basically. The f6 hour per week, and let's take it. Okay. Sorry, I did something wrong, but let's use scatter plot, and now it needs x and y. X will be, for example, our, I don't know, age, and y will be, for example, our hours per week. Age is called like this. Okay, so as you can see, we took only people who are aged more than 35, and we plotted them with hours per week. What we can do more, we can take, for example, let's take only young people. Let's take only young people, so those who are greater than 18, but lower than 65, maybe. And now, there are too many observations, so let's also change the number of observations. Let's take only first 5,000 of observations. So as you can see, there are less dots here. Yeah, and as you can see, what you can see on this okay, let's do like this. What you can see on this scatter plot, first of all, that people generally are working around this 40 hours per week, which is full-time job. There are lots of people who are working like 60 hours per week, so those are like full-time and a half hour part job, or half part jobs, half full-time job, half-time job, yeah. Secondly, people who are less aged are working more. It's general result, I would say. People who are aged like 60, 70, 80, those are working relatively less. It's logical, I would say. So this is what you can do, for example. So using scatter plot, using ilog, and using those conditional rules here, you can add titles and anything you want. Okay. So the next topic will be missing variables. So for this purpose, I will create some missing data frame, and we will remember how to create our data frame. So we need to specify the dictionary first. The column 1 will be like 1, 1, 3, NP none, which means it's missing. 3, 6, NP none, which again will be missing, and 8. Now let's create second column and create very similar data column. 3, 4, 3, NP none. Okay, so I have some missing data frame prepared for this. And as you can see, there is column 1 and column 2. Column 1 consists of some missings. Column 2 also has one missing. First of all, what are the methods in Pandas? Because this is missings, drop NA. There is drop NA method, which will drop each observation where there is a missing value. So that's the first option. There is also a drop duplicates method, which will help you understand how to handle duplicates observations problem. So as you can see, those first two observations were duplicates, and now if we call the drop duplicates method, it dropped our second observations from our data set, because those were duplicates. As you can see, we also had the third observation and the fifth were duplicates also, and it dropped the fifth observation. As you can see, there is no index for. So this is another method to handle duplicates, NAs, and there is also a method to fill those missing values. You can create fill NA, and fill NA basically, let's say that you want to fill those missing values with the mean of the column. And as you can see now, we had here a missing, and here we have some mean value of the whole column. And here also in seventh observation, we have a mean value of this column 1. If we call missing 1, missings call 1, mean, you can see that this is 3, 6, 6, 6, 6, 6, 6, 6, and this is basically this number. So this is really great. And here we have the last observation is missing in column 2, and it's also a mean. So you can for example fill those missing values with mean, with I don't know, with minimum value, with maximum value, with dominance, so the most frequent one. Yeah. So that's what you can do. You can also use, there are methods like method called ffill and backfill. So forward fill and backfill. And it will basically, the forward fill will get the upper observation. So here we have 6 because here we have also 6. So this observation, this missing observation will be changed with this 6. If we take backfill, this missing observation here will be taken with this observation. So I know it might be some chaotic right now, but I'm sorry for this, but I guess you will understand that there is a mean method, for example, dominant, any statistics, there is backfill, there is ffill, there are much more methods to fill missing values. Okay, so there is also a group by, which is really important. So let's say that we want to group by our data frame by age and call a mean, for example, on this. As you can see, all the columns, all the numeric columns now have the mean values for this age. We have a specific age here, from 18 years old to from 70 years old to 90 years old, and those are the means for these columns by this age. Yes, we can take, for example, hours per week only, and let's plot this out. So now you can see on the y-axis you can see how many hours these guys worked and what's their age. So what's their year age. So as you can see, people who are like around 20, 70, 80, 90, 20 are working less than people who are like 30. Those people who are 30 basically works approximately 40 hours per week or even more. And then this trend decreases basically because people gets older, yeah, they go for a rent and yeah, stuff like that. Okay, so to summarize everything up, I hope you like this video. We learned we learned some basic methods on data frames. We showed info methods, we showed describe, value counts, correlation, heat map, empty, is null, is NA, what's more, replace, rename method. We showed how to slice our data with log, ilog methods. We showed the trick with underscores in Python. We showed how to basically create a data frame, how to concatenate and join those, so merge those two data frames. We also showed how to visualize, how to use a plotting tool basically for data frames. When it comes to those plots, as you can see here, there are different kind of plots that we can create. Plot, and you can see that we can create like line, bar plot, KDE, density, area, pie, scatter. I don't know if I talked about this, but this is important. We showed how to handle missing data, what you can do with missing data. You can drop duplicates, you can drop missing data, you can drop duplicates, you can fill data with some methods like min, backfill, forward fill, and you can group by, plot everything. So I know this was a little bit chaotic, but it was my first tutorial, so I hope you like it, and leave subscribe, leave like, comment maybe, and let's learn together about Python and data analysis. And thank you very much. Bye bye.